guys, it's your girl Alapini Precious, and I want to welcome you to another class on economics, proudly sponsored by all three schools JAMB application. Okay, we're not new to all three schools JAMB app, so let's just go down to the class. Now we have method of economic analysis. Remember, in our previous class, we looked at the first aspect, which is the scientific methods, and now we'll be looking at the basic tools of economic analysis. Basic tools of economic There are some really basic tools that help us to understand the study of what economic analysis, and some of these tools include tables, we have charts, and we have graphs. These are what three basic tools for economic analysis. These tools can be divided into different sections, so we're going to take a look at each and every one of them in detail. Now, the first one we'll be looking at is what the tables. A table is used in what? A table is used in what? The representation of what? Data in economics. In economics, we refer to it as what we call the frequency table. We don't just call it a table, we call it a frequency table. It is used to represent economic data. For example, okay, first of all, a table comes in two formats. We have the row format, and we have the column format. So the row format is this way, where you have something like this. Okay. This is what the row format looks like, and the column format looks like this. So these are the two types of frequency tables you can find. You have the one represented in the row format, which is usually very common, and then we have the column format. You can find a frequency table in any of these formats. For example, now let's look at this data. Let them say in a class of 20 or thereabouts, we want to look at the distribution of fruits that students like. For example, let's say if they like let's just say oranges, mangoes, what can we say again? Let's say cherry, and then finally let's just use apples. A class of 20 students, and then they say 5 students like oranges, 5 students like mangoes, 4 students like cherries, and 6 students like apples. And they say let's represent this data in in a frequency table. Okay, so we can choose any of the formats and put it in a row format. Sorry about that. This is 5, this is 5, 4. Okay, so now let's draw our table. So this will be the fruits, and this will be the number of students, which is still the frequency. The frequency is just like the number of times a data appears, or the number of times an element appears. Okay, so we have oranges. The first on the table of fruits, we have oranges. You draw the line. We have mangoes. You draw the line again. We have cherry. And then we have apples. Oranges. Number of students that like oranges, we have 5. Number of students that like mangoes, we have 5. Number of students that like cherry, we have 4. And then the number of students that like apples, we have what? 6. So this is a simple representation of what a table looks like in economics, or a frequency table looks like in what? In economics. Don't forget, we have two formats. We have the row format and we have the column format. We could have represented this in a column format, or we represented it in the row format, which is still absolutely the same thing, just different what layouts. So that is it for tables. Now the next thing we're going to be looking at is what? Charts. The aspect of charts is a little bit broader than what the table is, because although a frequency table applies for each and every chart or graph that we're going to be looking at along the line of this class. Now, the first we'll be looking at is what? Graphs. Okay, sorry, we're looking at charts first. Charts. Now, when we're talking about charts, charts are also used to what? Represent what? Economic data. Charts are divided into 4. We have the what? The bar charts. I believe you must have heard about charts before now. Then we have the what? The histogram. We have the pictogram. And finally, we have what we call pie charts. We'll be looking at each and every one of them in detail. Now we're going to start with, don't forget we're talking about charts, which is a basic tool of economic analysis. And then we divided charts into 4 places. We have the bar chart, we have the histogram, we have the pictogram, and we have the pie chart. Now, bar charts on its own is divided into 3 columns. We have the simple bar chart, we have the component bar chart, and then we have the multiple bar chart. I believe I am not too fast. So even if I am, let's go over it all over again. We have the basic tools for economic analysis. The first thing we look at was what? Tables. It's divided into 3. We have tables, we have charts, we have graphs. Now we looked at table, and now we're looking at charts. And we saw that our charts are divided into 4 places. We have the bar chart, the histogram, the pictogram, and the pie chart. Now we're going to be looking at each and every one of them in detail so we can understand all of them individually. So the first thing we look at is what? The bar chart. The bar chart is divided into 3. We have the simple bar chart, we have the component bar chart, and we have the what? The multiple bar chart. Now let's see what a bar chart looks like. Okay. A simple bar chart. In a bar chart, elements are represented in bars. For example, let's take this table. Give a given economic data. Let's look at the table from here. We're going to be looking at a lot of tables, so permit me, I wrote them down. We're going to be looking at a lot of tables. Now, we have cars, and we have frequency. We have Toyota, we have Lexus, and we have Honda. The frequency here, we have 6, we have 4, we have 8. Now, this is a table. To represent this table in a simple bar chart. Now, this is what a bar chart looks like. This is our column for frequency. and this is our column for what? Cars, which is the elements that we're looking at. Now, they said this is our point zero. If you have seen a graph before, this is our point zero, and now we have 2, we have 4, we have 6, we have 8. Now, how many people drive Toyota, or what's the frequency of Toyota? The frequency of Toyota here is what? Is 6. So we're looking at it on our bar chart. Don't forget, a bar chart, you are drawing what? Bars to represent what? Elements. So since Toyota is 6, we're going to draw a bar. This is what a bar looks like. I'll be labeling here what? Toyota. Then we have how many? What's the frequency of Lexus? Frequency of Lexus is what? Is 4. So we're going to trace it. You draw a bar for Lexus. So this is what? Lexus. Now, the last one, Honda. What's the frequency of Honda? The frequency of Honda is what? 8. So this is what? Honda. So this is what a simple bar chart looks like. Simple bar chart. This is exactly what a simple bar chart looks like. Very simple. One bar to represent one element. One bar to represent what? One element, and the space is usually given between each of the what? Of the bars. There is always space between each of these what? Bars. Now let's look at the component bar chart. I hope the simple bar chart was simple enough to understand that the name implies simple bar chart. It is very simple. They will give you a frequency table or an economic data. Then you can decide to create a frequency table yourself, and then go ahead to draw your bar chart, your simple bar chart. The next one we'll look at is what we call the component bar chart. The component bar chart is a little more complex than the simple bar chart. Simple bar chart. Now let's look at the component bar chart. A simple bar chart involves just one set of what? Frequency. But a component bar chart involves more than one. It can be 3, it can be 2, it can be 5, it can be 6, it can be any number it wants to be. Then let's look at something. For example, if we're talking about 3 countries, let's say Nigeria, Ghana, and Cameroon. I want to look at what? We're looking at an economic data where we talk about the number of people that drive these cars in these different countries. For example, now we can say the first one we have, the first table we have is for Nigeria, the second table is for Ghana, and the third table is what? For Cameroon. Nigeria. We're going to use this table for both the component bar chart and the simple bar chart in Ghana, and then we have what? Cameroon. Okay, so if we say Paris, frequency. Permit my writing. I'm trying to minimize or maximize the space we have. So we have Toyota, we have Lexus, and we have Honda. Toyota, we have Lexus, we have Honda, we have Toyota again, we have Lexus, and we have Honda. Okay, so for Toyota, let's say we have 6, or let's just say, okay, yes, 6. We have, no, let's use 4. We have 2. We have 2. Then let's see, we have 2. We have 4. We have 2. Let's we have 2. We have 2. We have 2. Now let's look at the component bar chart for this given data. Don't forget, our frequency is always here on the x-axis, sorry, on the y-axis, and our cars is here on the x-axis, and this is our what? 0.0. Now, the first thing we're going to look at, okay, let's label our 2, 4, 6, 8, and maybe what? 10. The first thing we're looking at is what? Toyota. That's the first car brand. Now, Toyota, we're going to draw our bar. The first thing, okay, in the component bar chart, 1 bar will be used to represent these 3 countries. And then we can now shade and differentiate. Let me draw the first bar so that you can understand better what I'm saying. Then if we have for Nigeria, you have 4. If I'm correct. Then Toyota, we have 2. So the space between here and here is 2, right? So 4 plus 2 will bring us to what? To 6. Let's say this. Then plus 2 for Toyota in Cameroon. 2 plus 6 will have what? 8. So it's going to be at what? At 8. Then let's just say vehicles. So this is what a component bar looks like. One single bar is used to represent the frequency of Toyota, or the number of times Toyota appears in each and every table. Instead of drawing separate bars in a component bar chart, you can just draw it this way. You use 1 bar to represent it. Where the first shade, you can now put something like a chart here where you say, you give us something like this, that this represents Nigeria, this represents Ghana, and this represents what? Cameroon. Be sure to state and explain how you are using the component bar chart, so that when somebody sees this now, when somebody sees your bar chart, they know that for the frequency of Toyota in Nigeria is 4. The frequency of Toyota in Ghana is 2, and then the frequency of Toyota in Cameroon is also 2. Now let's go to the next one. Let's look at Lexus. I hope already very familiar. So this is 8. So we can see draw directly from here. When we add the frequency, 2 plus 4 is 6. 6 plus 2 is what? 8. So we already know that our bar is standing at what? At 8. So now we start with Nigeria at first. So let's look at it now. Lexus in Nigeria is 2. So we trace our 2 and then we mark it. And then we shade it to show to our examiner that Nigeria, the frequency of Lexus in Nigeria is 2. Now the frequency of Lexus in Ghana is 4. So from 2 plus 4 we have 6. So we're going to be tracing it as 6. So we know that in Ghana the frequency is 4. Then the next thing we look at is Cameroon, or the next place we look at is Cameroon, which is 2. So 6 plus 8, 6 plus 2 is equal to 8. So we know for a fact that the frequency of Lexus in Cameroon is 2. I hope we are following exactly. Now let's look at the last one we have was Honda. So we're drawing the last bar for Honda. 2 plus 2 plus 2, this is 6. So we know that our bar will be standing at its highest pitch, which is what? 6. So this is what? Honda. So now the frequency of Honda in Nigeria is 2. Sorry. 2. Start from the bottom. 2. The frequency of Honda in Ghana is also what? 2. Right, this is Ghana. And then the frequency of Honda in Cameroon is also what? 2. So this is what a component bar chart looks like. Forgive my rough representation. It doesn't look exactly equal, but I hope you understand where I'm driving at. Forgive my drawing. So this is what a component bar chart looks like. The data we are given is more than, the frequency is more than 1, which is at different what? Countries. It can be brought in another way. It doesn't necessarily have to be what? Cars and countries. So now we're using cars and country as an example. We have more than 1 country, and then we're trying to represent the data in just one graph. So we're using a what? A component bar chart to represent this data. Now let's look at the last aspect, which is what? The multiple bar chart. So like I said earlier, I'll be using the same table to represent everything. Be using the same table, although we can, let's just use the same table. So better still, this is a multiple bar chart. This is frequency, and this is what? Cars. So now a multiple bar chart. Now in a component bar chart, they are related, but they are a little bit different. In a component bar chart, we're using 1 bar to represent all the 3 elements. But here in multiple bar charts, we're using different bars joined together to represent our data. Different bars. So if it's 3 elements we're going to have 3 bars per car. We're going to have 3 bars per car. For example, now, let's say our 0 mark. This is 2, this is 4, this is 6, this is 8, and this is what? 10. So now let's see. Toyota in Nigeria. We're looking at Toyota first. Mind you, my line is way longer because the bars will now be more than the bars we've seen in the prelim, both the simple bar chart and the component bar chart. So we have 3 countries. Now the first one we're looking at is what? Toyota in Nigeria. Toyota in Nigeria is 4, so we're going to draw the first bar. That is for Toyota in Nigeria. We're following, right? Then we have Toyota in Ghana is 2. So we're going to draw it this way. 2. Like I said earlier, the bars are joined together. Then we have for what? For Cameroon is also what? 2. This is not how it's supposed to be, but I'm just giving you an illustration. So this is how it looks like. This is for Nigeria, this is for Ghana, and this is what? For Cameroon. So if we're following the order this way, you should know that the first bar you see is for Toyota in Nigeria, the second bar is for Ghana, and the second bar is for what? For Cameroon. Now the next one we're looking at is what? We're looking at Lexus. Lexus in Nigeria is 2. Lexus in Ghana is 4. And Lexus in Cameroon is what? 2. Then the next one we'll look at, and lastly, is what? For Honda. Honda in Nigeria 2, in Ghana 2, in Cameroon was 2. Don't mind my table and illustration. This was just in my head. It may look a little bit tacky, but I hope you are getting the message I'm trying to like pass across. So the Toyota, we have Lexus, we have Honda. This is what a multiple bar chart looks like. Multiple bars, as the name implies, multiple words, bars, more than one bar per element. Now we're done with bar charts basically. So don't forget, bar charts, where we use bars to represent what economic what data. It's divided into three. We have the simple bar chart, we have the component bar chart, and we have the multiple bar chart. I will look at the simple bar chart, where one bar is used to what represent each element, and there's usually a space given between what each element. Is not conjoined together. The same thing for component bar chart. It is not conjoined together, but one bar is used to represent more than what one element or one frequency of a certain what element, depending on how the question comes. And then we have the multiple bar charts, where multiple bars are used to what represent data, where each bar represents a certain what data in a what certain region, depending on how the question comes. I hope you understand this illustration properly, although we'll still go over everything all over again by the time I'm done. So this is it for what bar chart. The next thing we are looking at from before I listed is what we call the histogram. Histogram is a little bit similar to bar charts. Histogram and bar charts are similar. We use bars to represent elements, but in a histogram, okay, I think I still have to clean this. Keep this here. Histogram is related to bar chart, like I said earlier, and it is used to also represent data using what bars. But in the case of histogram, histogram looks more like a multiple bar chart, because although it is not the same, in histogram the bars are joined together. For example, using the table I gave earlier, where we have what size and frequency. Don't forget, frequency is the number of times an element appears in a given set of what information or data. Then we have the Toyota, we have Lexus, we have Honda. 4, 6, 8. Now, if we were to draw a histogram, we have 0 points, we have frequency, and we have what cars for elements. We have 2, 6, 8. Toyota here is what 4. Then we have Lexus, which is what 6, and we have Honda, which is what 8. Forgive my drawing. Okay, let's add a little more from the questions we have here for a histogram. We have the Benz 2, and we have the Kia, which is what also 4. Okay. Oh, sorry, made a mistake over there. Then Benz is 2, then Kia is what 4. I wanted to make it a little more representative, so I tried to add more. So this is Toyota, this is Lexus, this is Honda, this is Benz, and this is what? Kia. So, like I said earlier, the histogram is a little bit more similar to what the simple bar chart, but in this case, the bars are joined together. There's no space given in between. Like for a simple bar chart, now you see when we draw the bar, we give a little bit of space before you draw the next bar, and give a little bit of space, and so on and so forth till you get to the end of your data. But in case of histogram, the bars are joined together, but each of the bars represent a given set of what elements. So that is it for histogram. It's very simple and very self-explanatory, and it is very easy to what to understand. The next one we'll be looking at is pictogram. Pictogram is very self-explanatory. In this case, pictures are used to what? Are used to represent data. Use a picture to represent what? A data. So for example, if we are talking about what? Apples, just those are pictures of apples will be used to represent this data. I would have drawn, but forgive my skill of drawing, as it is not so good. But just know that a pictogram is a chart whereby pictures are used to what represent given data. For example, if we're talking about 4 apples in pictogram, you're going to see a picture of what 4 apples. We're talking about 4 oranges, we're going to see a picture of what 4 oranges. If we're talking about 4 pineapples, we're going to see a picture of what 4 pineapples. Now let's go to the very important, although it is simple but very tricky part, which is what we call the pie chart. Pie chart is simply the representation of what economic data in a circle, and in this case, we use a circle is 360 degrees. So information in a pie chart is represented in degrees, and the higher degree was 360 degree. Don't forget, in a pie chart, a circle is used to represent economic data, and the frequency is represented in degrees. So we're going to look at this particular example for me to explain pie charts better. Now, they said the table below represents the number of fruits consumed in a year by a family. Now, this is the table and we have frequency, we have banana, we have orange, we have cashew, and we have grape. So banana we have 120, orange we have 200, cashew we have 160, and grape we have 240. Now, the first thing we are going to do is to represent the frequency in degrees. How do we do this? The first thing we'll do here is to calculate the total frequency, which is the summation F. Total frequency here we give us, this is 120 plus 200, this is 320 plus 160, which is 480, plus 240, which is 720. Now the first thing we do is to calculate bananas. In calculating the frequency in degrees, it will be the number of bananas over the total number of fruits, which is the total frequency, which is 720, multiplied by 360 degrees. Let me put this down a little. So now looking at this, with our normal knowledge of division, we have this is 12 here, this is 6 here, this is what? 60. So banana is equal to what? 60 degrees. Now let's look at orange. Orange, which is equal to what? 200 over the total frequency, which is 720, multiplied by 360 degrees. So we have 10, we have 36. 36 here, 1, we have 36 here, 10. So 10 times 10 equals to what? 100 degrees. So orange is what? 100 degrees. And let's look at cashew, which is what? 1 cc over 720 multiplied by 360. You can use a calculator if you are with one, or I will doing mine from here. So this is 8, this is 36, 36 here, this is 10, so this is what? 80 degrees. Now the last one we'll be looking at is what? Grape. So grape is what? 200 and what? 40 over 720 multiplied by what? 360. So if we have, here we have 120, here we have 360. 360 cancel 360, so it goes to 220 degrees. Now it's time for us to draw the pie chart. We already have this here. If you add up all the answers we got in degrees and you do not get 360 degrees, just so that you have made a mistake and you are supposed to go back to check. But here, if you add this 160, 160 plus 80, 240, 240 plus 120, we have what? 360 degrees. Now this is what we trying to get the frequency in degrees, so we can represent it in our table. This is not in our chart, in our pie chart, our circle rather. This is not the end, this is just the beginning. Now let's draw the pie chart. Sorry, I'm cleaning up the question. You can take it back a little bit for you to get the question if you really need to. I don't want to clean this part, so we don't clean what we have managed to solve down. Now we'll draw the circle. I'm not using a mathematical set. This is freehand drawing, so there will be a little bit of mistakes. Normally, if you have to draw a pie chart, you're going to use a mathematical set and then you measure and come up with a very accurate degree. But this is a freehand sketch. You don't expect it to be correct. So we'll look for our points here and then first draw a line to the point. Now, the first one we have is 60 degrees. From our normal knowledge of mathematics, this is supposed to be 90, so 60 comes before 90, so at least 60 will be somewhere here. We have 60 degrees for banana. The label is banana. Then we have oranges, which is 100 degrees. So looking at it, this is supposed to be, to draw it straight, this is supposed to be 180, but it's not correct. This is 120. It's supposed to be a 0.160. So at least here we give us 100 degrees, a little bit above 90. Then we have orange. Then we have cashew, 80 degrees, not so much, it's somewhere around here. So we have 180 degrees for cashew. Then we have the last aspect, which is the grape. This should be 120 degrees with addition and subtraction, give or take. Then this is for grape. This is simply what a pie chart represents. As you can see, the first thing we did from our frequency table was to calculate the frequency in degrees, which we did for each of the elements on the table, and then from there we were able to draw out our pie chart. Now, in a situation like this where they give you the pie chart and ask you that how many or what is the frequency of grape in the pie chart given above or below, however it comes. What you do is simply the same way we did frequency over total frequency multiplied by 360 degrees, which is this. We're going to do what? Do the degrees all over, sorry, the degree all over the total degree, which will be 120 over 360 multiplied by what? The total. In a case like this, I forgot to mention, they will give you the total frequency. The total frequency will be given. So in a situation like this where they say, okay, the total frequency is what? 720, and they ask us what? Find the number of grape. So we're going to have 120 over 360 multiplied by 720. So this is 12, using 12 is 10. This is what? 30. So this 3 here, this is 240. So 240 is what the frequency of what grape are represented in the table. Don't forget, they will give you the total frequency, and then they will ask you that using the pie chart given above, what is the frequency of orange, or how many oranges did the family consume in a year? Or they'll ask you how many bananas did the family consume in a year? Or they'll ask you how many cashew did the family consume in a year? Or they can ask you what is the frequency of what cashew. So it is very not, although it is not so simple, but it is very simple once you understand the basics, and this is the basic. When you want to draw a pie chart, the first thing you do is to what? Calculate the frequency in degrees. After calculating the frequency in degrees, you will draw your circle, and then you use your mathematical set, or if you are also using freehand, of which you should have mathematical set, to carve out the angles, and then you measure out the angles rather, and then give a detailed pie chart where you label each of the degrees. You label, if orange is 100 degrees, where you have 100 degrees, you label it orange. If cashew is, 80 degrees, I said 180, 80 degrees, and then if grape is 120 degrees, you put there was grape. So that is it for the charts. We looked at the bar chart, the pictogram, the histogram, and we have looked at your pie chart. Now, the next part and the final part of the basic tools of economic analysis we're looking at is the graph. A graph is a tool used for studying economic analysis. And I'm sure with your knowledge of physics or mathematics, you must have come across graph at one point or the other. You must have come across graphs. So now, like I said earlier, the table is a very vital and crucial part of these basic tools of economic analysis, where while we're looking at charts, at each point we had our frequency table guiding us, and the same thing happens in graphs. Now let's look at this simple example to illustrate what graphs look like. So in the frequency table provided above, now we're going to draw out a graph. We have price and we have quantity. We have 40, we have 48, price in naira. We have 55, we have 60, and we have 70. In economics, graphs are also known as curves. You can also say it was a curve. Sorry about that. Well, so now here, sorry, let me complete the table. We have 6, we have 5, we have 4, we have 3, we have 2. So let's take this as a graph. The y-axis, we have the price in naira, and here we have the what? Quantity. Now looking at the first aspect, this is what, so we're going to start from the smallest. Let's just say this is 40, this is 48. This is simply a rough sketch because we're using a board, we're not using a proper graph. This is 55, this is 60, and this is what? 70. So now let's start with 0. So we're not using a proper graph, so let's just manage this sketch. We have 2, we have 3, we have 4, we have 5, we have 6, and maybe 7 and thereabouts. So now from the table they said when price is 40 naira, quantity is what? 6. So we're going to trace down to what? 6. So this is our point here. And then when price is 48 naira, quantity is 5. So we're going to trace down to 5. And then when price is 55 naira, our quantity is 4. We're tracing down to 4. Forgive my rough sketch. And when price is 60 naira, our quantity here is what? 3. And when price is 70 naira, quantity is what? 2. Now, let's look at what the slope of the graph coming down, going through the what? The point. This is a downward slope. The most important aspect of graphs or curves is what? The slope. And the slope can either be negative or what? Or positive. The slope is usually positive when the price and quantity are going in the same direction or when they are moving in the same direction. For example, let's say as price increases, quantity increases, we will have a positive slope. But in a case whereby they move in the opposite direction, a negative slope is to be expected. For example, as price is increasing, quantity is decreasing, or as quantity is increasing, price is what? Is decreasing. That's vice versa. We should expect what? A negative slope. And in this case, the slope is actually negative because the what? Price and quantity are moving in what? In opposite direction. In this case here, as price is increasing, we can find out that our quantity is also what? Decreasing. So the slope of this graph is what? Is negative. This graph will have what? A negative slope. This graph is definitely going to have what? A negative slope. As price increases, quantity decreases, which is, as this is going this way, this is going on this way. But in a case whereby it is going this way and going this way, where we have a what? An upward slope. Don't forget, a negative slope is downward direction, but a positive slope is what? Is going what? Upwards. For example, if in a case whereby we have, let's look at it, let's rearrange it, let's say 2, 3, 4, 5, 6. In this case now, as price is increasing, quantity is also what? Increasing. Now let's take a look at what our graph will look like in this case. So at 40, we have 2. At 48, we have 3. At 55, we have 4. At 60, we have 5. At 70, we have 6. So in this case now, look at it now. our slope is going upwards. So the slope of this graph is going to be what? Positive. Or the slope of this graph is going to be what? Positive. Now we've come to the end of what? The basic tools of what? Of economic analysis. At the very beginning, when we look at basic tools for economic analysis, we looked at three aspects. We have the tables, we have the charts, and we have the graphs. And then we look at the tables, which is used in what? Assessing or representing economic data, and it is usually represented in two formats. We have the row column and we have the row format, and then we have what? The column format. Then we went on to look at what? Charts. We looked at the bar charts, look at the pictogram, we looked at histogram, and we looked at what? Pie charts. And then we look at what? The graphs, also known as what? Curves. Is the example. We have the supply curve, we have the demand what? Curve. And then we talked about the slope. We have the positive and negative slope, where when the slope or the curve is actually a downward curve, it is a what? A negative slope. And then when we have an upward curve, we have what? The positive slope. I believe that when you open the O3 School JAMB app, which is available on your Android and laptop, you'll be able to find questions that you can answer. So many past questions actually that you can answer on basic tools of economic analysis, and you will be very, very sound when it comes to this. If there's any question, you can leave it in the comment section, or you can revise back to the video and then find all the answers to your questions. Thank you very much for listening.